Assalamualaikum warahmatullahi wabarakatuh. Today our group will present module 8 and it is acetic acid synthesis and applications. And our team members are I am EH1105B binti Ramzi, Nur Anis Amira binti Azmi and Nur Ain Basira binti Ahmad Aswadi. I will explain about history of acetic acid. Acetic acid is an organic compound belonging to the carboxylic group. Its formula is H3COOH, where a methyl group is attached to a carboxyl functional group. Its IUPAC name is ethanoic acid. Acetic acid is the main constituent of vinegar and is known since ancient times. Vinegar solution contains acetic acid and water, where ethanoic acid is between 5% to 20% by volume. The acetic acid in vinegar is responsible for its pungent smell and the sour taste. The first person to extract acetic acid from vinegar was Muslim alchemist Jabir ibn Hayyan Gibber, 721 till 815. The pure compound was not produced. However, for another 10 centuries, when the German chemist Georg Ernst Stahi 1660 till 1734 extracted acetic acid from vinegarian 1700 by distillation. The structure of acetic acid. The structure of ethanoic acid is given by H3COOH. In the solid state of acetic acid, there is a chain of molecules with individual molecules connected through hydrogen bonds. In its vapor state, its dimers are found at a temperature of about 120 degrees Celsius. When in the liquid phase, its dimers are found when present in a dilute solution. Physical properties of acetic acid. Ethanoic or acetic acid has a pungent vinegar odor and sour taste. It is a colorless liquid. It boils at 391 Kelvin. Its density in liquid form is 1.0449 G/centimeter cube. It can mix with water, alcohol, either in all proportions. In water, it dissolves with the evaluation of heat and contraction in volume. It is corrosive in nature and produces blister when in contact with the skin. Sulfur, iodine, and many other organic compounds are dissolved in it. Now, I will pass to Anis to explain about the reaction of acetic acid and equipment to produce acetic acid.
Thank you, Elizabeth. Next, I will continue with reaction of acetic acid. Acetic acid undergoes nearly all carboxylic acid reactions. Acetic acid undergoes decomposition when heated above 440 degrees Celsius to yield either methane and carbon dioxide or water and ethanol, given by the equations. First equations, acetic acid heated then produce carbon monoxide and methane. Next, acetic acid heated then produce ethanol and water. When exposed to acetic acid, some metals such as magnesium, iron, and zinc undergo corrosion. This reaction leads to the formation of acetic salts. When magnesium reacts with acetic acid, it gives magnesium acetate and hydrogen, such as in the equation. Next, acetic salts are formed when acetic acid reacts with alkalis as described in the equations, which is acetic acid react with potassium hydroxide, produce potassium acetate and water. Compounds formed on reactions with carbonates are acetic salts, water, and carbon dioxide, which is first equation is 2 mole acetic acid react with sodium carbonate, produce 2 mole sodium acetate plus carbon dioxide and water. Next, acetic acid react with sodium bicarbonate, produce sodium acetate plus carbon dioxide and water. Next, this is the equipment in producing acetic acid, which is reactor, flash vessel, and drying column. For production process of acetic acids, this is the flow scheme of the Monsanto process for acetic acid production. Next, I will continue with methanol carbonylation. Under relatively mild conditions, the reaction takes place in the liquid phase. The water-gas shift reaction produces non-condensable byproducts, primarily carbon dioxide and hydrogen, which are vented from the reactor. The volatile and toxic methyl iodide is recovered by combining this vent gas with off gas from the light ends column and sending it to a scrubber. A pressure reduction valve removes the liquid from the reactor and sends it to a flash vessel, creating a gas and liquid phase. The dissolved catalyst complex is recycled back into the reactor in the liquid phase. The gas phase is transferred to a distillation stream for purification containing the majority of the acetic acid product, water, methyl acetate, and methyl iodide. Methyl acetate, methyl iodide, and a portion of the water are taken from the light ends column and recycled to the reactor. Wet acetic acid is obtained as a byproduct of this column and sent to the drying column, where dry acetic acid is removed as the bottom product. The overheads of the drying column, which contain 35% acetic acid and water mixture, are recycled to the reactor. The plant continuously circulates a fixed amount of acetic acid and water. Heavy byproducts, primarily propionic acid, are removed as bottoms from the dry acetic acid delivered to the product column. That's all from me. Next, I will pass to Ain Basirah.
So now I will continue with application of acetic acid in food industry. First of all, vinegar. Acetic acid is present in all types of vinegar, from weaker table vinegar through to pickling varieties and more concentrated products. Being present in vinegar is by no means the main use of acetic acid. It just happens to be the best known. Next is acidification. Acidification is simply the bacterial oxidation of ethanol to produce acetic acid and water. This bioprocess technology is studied and systematically utilized to improve the quality of food in terms of texture, taste, mouthfeel, color, and prolong shelf life. The overall concept has grown into generating different types of food and beverages produced in a cheap and sustainable way. Then, acidulant. Acidulants are essential ingredients to additives that are generally used to improve the taste of food and make it sharper, and also used in the making of edible packing. And last but not least, acetic acid also had been used as flavoring agent. So next industry is modern medicine. Acetic acid possesses excellent antibacterial properties and is used as an antiseptic when used as a 1% dilution, and also used as an alternative product to prevent infection and kill bacteria. Next, adhesive and paints. A reaction consisting of ethylene, acetic acid, and oxygen over a palladium catalyst creates the vinyl acetate, which can then be polymerized to a number of different polymers, which are the common components in adhesive and paints. Lastly, discolors and rust removal. Acetic acid reacts with the rust, breaking it down from a solid into a readily removable liquid. Okay, now I will continue with example of companies. First company is BP Petronas Acetyls Sdn Bhd. BP Petronas Acetyls Sdn Bhd (BPPA), an acetic acid factory, is a non-operated joint venture between BP and Petronas, based at Kerteh, Terengganu, on Peninsula Malaysia's east coast. The BPPA factory produced over 500,000 tons of acetic acid per year for distribution in Malaysia and export to South Asia as well as North and South Asia. Next, ORC Chem Technologies Tendian Berhad. ORC Chem, located in the heart of Selangor, is one of the best acetic acid suppliers. It provides only the highest grade acetic acid to its customers as one of the leading acetic acid suppliers. That's all from us. Thank you.